finally back after a bit of a break from the videos. Been a bit busy just trying to catch up with work and get a few things done, but I still want to carry on doing videos as and when I get a chance. So I thought I'd come back and show you. Obviously I've had this Haas VF0E for, must be sort of 5-6 weeks now. It might even be a bit longer. I'll have to look at when it got delivered. But anyway, I've been using it, done a few parts, not been flat out on it because I do a lot of welding and bits and bobs as well, so I'm not using it every day, not learning the machine every day, but I've come a long way with it since it got delivered. So what I wanted to show you, that when it was delivered, it had half of the, let's just take the camera off of here, it had half of a Renishaw probing system on it. So it had the probing system when it was new at a guess, and it had this OMI fitted, which is one of the early original ones, but that's all. And it had some probing cycles inside the control, but not a lot else. So I managed to find someone via a Facebook group, I think it was on, possibly on the Titans of CNC group, speaking to them, asking about probing cycles and bits and bobs, and somebody actually had for sale in the States, a fella called Bob. He had for sale one of the early OMP 40 probes, work probes. So we got that from him, from the States. That's fitted up there. Rather than do that, let's actually bring it round. The downside of this, because these have air coming out the spindle all the time when they're running or on or tool changing, the compressor will kick in and become a bit noisy. So there's our Renishaw probe. This is an OMP 40, again one of the earlier ones, and I had somebody come in and help set this up, and also while they was here, or before they come here, I bought from them the toolsetter, which is the Renishaw TS27R. So that's a wired toolsetter, purely because this receiver only has one channel, so it can only talk to one thing at a time. So rather than being able to get that also wireless, it has to be wired, which is no real drama to me. And considering the cost of these new can be sort of £5,000, £6,000, £7,000, this whole thing, obviously on top of buying the machine, just to get it up and running and all in as it stands now, probably cost me an extra 1,200 quid. So I'm definitely not going to argue with that. And when we had the person come in, he showed me some probing cycles, and then through them I've added and just derived shortcuts for all the ones that I use more often. So probing the corner of a workpiece, very similar to the new Haas controls, the next generation, that have got these sort of cycles in a visual quick code and probing, whereas obviously this one hasn't. So I've got probing a corner, probing a bore with an island, probing a boss, single surface, pockets, cubes, pocket with an island, and then the other two are just calibrations, and this last one's just a program I'll leave on here for soft jaws. So having the probe, it's just in a league of its own, having this, although I'm not using the machine all the time, and a lot of people would say you don't really need it. Half of it was fitted, so in the cost of it, in the grand schemes, no, I wouldn't buy one new for £7,000, but then for the 1,200 quid that it cost me to buy the OMP 40 and the TS27R, now I've got the tool setting, length and diameter, and I also can probe the workpieces, because before I was using what most people use, just like a 3D Heimer, which was good, but it's nowhere near as accurate as the probe setup. So I'll come along, I'll show you a couple of bits what we've been busy with recently. This is a project for someone, Ford Fiesta. They brought this along with the Z-Tech engine there, and they wanted to fit a supercharger to it. So they asked me, they supplied me the supercharger, which is a Rotrex style. No one fixed one, or no one has fitted one to this engine, so there's no brackets or mountings or anything like that. So they said, can you mount it all up? So we've made a custom bracket designed down there to fit, and we also incorporated the idler pulley and there's also a self-tensioning belt pulley down there as well. And then they supplied this small alternator, just needed it mounting and getting everything in line. Machined this bracket here to go on, and then we've done the pipe work. We've done electric hydraulic power steering pump along with a custom mount and bracket for that. And also they supplied the basic intercooler, and I just machined and made up and welded on the mounting points and fitted it to the car along with an intercooler that you can see down there. So that's kept me busy for a while, but that's now due to go. We've also been doing some bits here. This we're just put in the blaster, cleaned it all up. This has got to have an adapter plate. This needs to be cut off and have an adapter plate for a throttle body. It used to run individual throttle bodies, which were these ones here, which are Gen V, but they didn't want to use them as individual throttle bodies anymore, so we've took the spindles out and the linkages, and then they asked me to blank up where the linkage used to go, so obviously you don't have no vac leaks. So we've sealed up the ends there. We machine these in the mill. They're like a top hat that sits inside on a seal to stop any leaks there. And then where the spindles pass through the center here, this piece used to be an open bore, and then now we set these up in the mill. We machined this bore out to a perfect size because it was just a tapered cast, and then we machined these square plates which have actually got a round boss machined onto the other side, so it's like a top hat that's sitting and seal both of them, so again there's no leaks from the side. And then the job I'm going to go through and show you today is a cylinder head off of a Ford CVH engine, and the customer had this pulley CNC machined by someone else, done a really nice job of that, and a custom mount in here. This pulley's driven off the camshaft, which obviously comes in, and there's a key on the back of here, but they want to use this as a cam trigger pickup, so they asked me to machine a trigger ring. So we took this pulley off, took it apart, and we drilled and tapped the pulley. You can just see it there. Try and get a better view for an M3 button head, and there's 3 of them drilled and tapped, and then we machined this steel ring out of 3mm mild steel, machined some slots in it that they asked for, and then we've put one trigger pickup tooth on there. It's a very, very tight fit. If you can see as I turn that round, that clears that bolt by probably about 1 millimetre. But as they say, clearance is clearance. Now what I need to do now is machine up a mounting point off of these 2 bolts. It's where they've asked for it to be positioned. And then the Hall effect sensor has got to come on and be mounted on here to pick up that trigger. So we have to machine something for that. And that is what this video is going to be about. So let's take you over to the computer. I've been using Fusion 360 for about the same amount of time as I've been using the mill for. So again, it's new to me. There's probably better ways of doing some of this stuff, but I'll show you what we've been working on for that mounting bracket. And there it is. Try and balance this here for a second. So that is how it's going to be. Try and get rid of that reflection a little bit. There you go. So there's the bracket. So here and down here are the mounting points onto the cylinder head, and then this is the hole for the sensor, and then this is M6 threaded hole which secures the sensor in place and stops it moving. And now all I've done is done a pocket here just to save a bit of weight. There's no need for it to be really heavy or completely solid, so it saves a bit of weight and looks nice. We haven't got the chamfers on the sketch. I tend to leave them off and just add them on afterwards. And we've got 2 ops because we've got to orientate this once, taking everything off here, and the other one starting off this back profile. So that is done. We've created our programs, and what I'm going to do first off is I'm going to show you how we set up the stock and set the work offset using the Renishaw probe. This is the stock, 2.5 inch square bar. It's yeah, 63.5 square, and then I think we cut this at about 95 in length, which brings me to one more thing actually. I'll show you, nothing too exciting, but we bought a new saw because the little Femi saw that we use for all the little accurate pieces and pie cuts was not really coping with 50mm steel bar and big alley sections. So we bought this saw, this one, there you go, SIP 12-inch metal cutting bandsaw. When I got it, the blade looked okay, but it cut terrible. The ends were not square at all. They was off by up to sort of 3mm where the blade was bending out. I thought it was just the quality of the saw. I was wrong, it was just the blade. Put new blades on it, and that is the cut straight off of there. That's not been touched. That is exactly how it cut, and it is almost perfect. So well happy with that. So yeah, there's our new saw for cutting all our big stock. It's another car we've got here with a load of work on, but I'm not going to go into that one yet. So we're going to sit this here on some parallels and then just come off, and we'll probe the top surface, set Z0 at the top, and then come off and make this corner G54 0. So let's put you back on the stand. And we'll go through. So the first thing I need to do is jog the probe roughly into a position. We'll get that. Little trick that somebody showed me: if you get pallets, you get deliveries, and you get the spring steel strapping that comes on it, put it up into a little S shape there and use that as a real cheap way to hold your parallels in place. Blinding little trick, and literally costs nothing. So if we get a delivery and it has this spring steel strap, I'll just cut it into sections and keep it in the drawer ready to use as and when I need it. But I've had them ones for a long time now, and they do seem to last ages. So let's jog it into place. What we need to do is we need to be roughly over the corner of the workpiece where we're going to go, because obviously the probe's going to pick it up, but it needs to roughly already know where it is. So just by eye, I'm going to come down there on the corner of that. There, I'm on the corner, not too long to do it. And then, don't know if you'll see again with the glare in here, so I do apologise. I'll go into programs. I'm going to go into probe corner, bring that into the memory, and then if I go into edits, you can see a bit clearer. You may or may not be able to see. I've wrote some little comments there that just reminds me of what it's going to do. So probe corner sets the front left corner G54 and Z0. But first I need to set the XYZ part set 0 and add my offset of the tool. So what that means is that once positioned over the corner, I go into the offsets page and I just part set 0, roughly tell it where it is. But then on this one here, I just need to add my probe length, which I keep written here, 136.506 minus 136.506, and I add that to that. Then that roughly knows, that thinks it's centered there already, so that gives it the guide, because when it moves off 10mm off of X, 10mm off of Y to come down to probe. It knows where it is. If I didn't set that, it wouldn't know how close it was to the material to start with. So now I can go into memory, probe corner, and press cycle start. So there it is, touching off on X, touching off on Y, come back, touch off on Z, and you'll see these change. And that is it. So that is now part set 0, G54 is that front left corner. So what I've got, took me a little while to figure this out as well. We've taken our programs from the computer, we put them on a USB. This machine had a USB emulator fitted. Took me all day to figure out how to get it working the very first time. There's the compressor, do apologise. So we put the USB in. Now that automatically loads it into the floppy drive. So we come back in, we'll go to edit, F1, and we'll go across to floppy directory, press enter. Now that's reading what's on the USB, which is now in the directory. So I've got CAN trigger, that stands for CAN trigger op1 and op2. We're going to leave it on op1. And that's loading it up. And there it is, jumps into the memory. While I'm here, I might as well load the second one as well. There is going to be a third op, but I haven't broke that yet. That's basically just facing off the material that we've used to hold the part. Rightio, so now I can go into list programs. CAN trigger op1, select, go to memory, there we are. I like to be on the machine current commands, and then also like to go down and have distance to go set out there. So we'll shut these doors. I'll tell you what I will do actually, before we get carried away in there, I'm going to show you I'll go through, and as you've seen the probe now we set the G54 for the workpiece, I'll show you how we set a tool. So let's come MDI, let's select what tool have we got here. We'll do one with a diameter that doesn't really need, so let's set tool 8. So we'll go T8, forward. Now there's plenty of cycles where you can just set the length. So on a drill, for example, you don't need to know the diameter. I tend to do all of them with diameter rather than change backwards and forwards. So in our list of programs, we've got one here which says auto tool set. Let's go down to that, enter. Now what I've done is I've done these as generic, so there is information you have to change on what tool you want it to, what tool offset you want it to change, and what height offset corresponding to that tool. So if I now go into memory and edit, this is the Renishaw cycle, G65, 9853. B3 means it's going to do the length and the diameter. B1 is just length, B2 is diameter. So I always leave it as B3 personally. Tool 8, which is what I'm actually on because I set this one last, so it's going to set tool 8 and it's going to do the diameter offset for tool 8, and then S12 is a rough gauge of how the diameter of the tool. The tool is actually a 10mm tool, but you don't have to be that accurate, it just needs to have an idea. So if I go into memory and then we'll press cycle start, comes over to the tool setter. spindle turns on, rotates in reverse so as not to damage the tips. Touches off once, and then a second time. Comes off one side of the tool setter, touches off twice. Moving on to the other side. And there we go, that is that tool done. Now one thing I will mention is, if you go into your offsets page, so there we are, we've just done tool 8, so our length is 116.858, and that's a 10mm end mill, and that's measured it at, well, it's going to work out 10.006, so 6 microns over 10mm, so that's close enough for what I'm doing. But if you're using the auto set, where it will come over and manually it will automatically move the table and the tool setter into position below the spindle, then you must tell it an estimated length here that's within, I think it's 5 or 10mm. If not, it doesn't know this, and because it's going to come down above the tool setter, if you don't tell it this, then it can come down and crash into it. So what you do, I tend to do it first, or you can write it on the tool if you keep the same tools in the same holders, is before doing the auto measure, I'll come in, touch it off of there, and then I'll with thumb, and I'll say, right, that tool, 120. So I'll type in 120 first, and then I know it won't crash, and then the actual measurement, 116.858. So you must do that first. If you don't put a measurement in there, or you put something that's too long, or more so, if it's too long, it won't be an issue. If you say it's too short, it will come and crash into the top of that. So that's what you don't want to happen. But anyway, now that is done, we'll go back into our programs list, go back into Op1, into the memory, current commands, got distance to go, we've got to have it there, everything's set up. There's the list of tools I've got ready for the job. So now I can close the door, hit cycle start. Come over to the face mill. And away we go. Now I won't show you all the program, I'll let this op finish. Once this op's finished, I'll blow the part off, and then I'll bring you back and I'll show you how we set up and switch and reset with the tool pro to do what to do. See you soon. Right, so the first op's finished. I'll show you the part here. There it is. So what we're going to do now is we're going to take this out and we're going to flip it up so this surface becomes the top, and we'll touch off the probe here on the X, Y and Z to set the new datum on this corner, and then we'll machine this top half. It's going to do a pocket in here, drill and tap M6 hole. It's going to do a bit of engraving along there. So we'll get that set up and we'll show you that now. Right, so let's undo this part, get this taken out. So there you have it, just give you a better look there. So yeah, now we'll stand it up and we'll come in and we'll work on this and taking this bit down. What I'm going to do is I'm going to sit it on the vise and I'm going to put this bit of alley across the front there, and I'm just going to clamp it like so, just to try and not mark that front. It might leave a tiny line in that corner, but that'll be okay. spring steel parallel keeps. Like to clean them all off as I take them out, rather than take them out covered in coolant. Anyone wondering about the green coolant, it's Roco V-Cut SS, I think it's called, but I wasn't expecting it to be green when I bought it, but to be fair, it's actually really good. And I can use it in the milling machine, I can use it in the lathe, I can use it on the bandsaw, and I emailed them to check, and I can also use it in the plasma cutter as a sort of antibacterial, antifungal, which means I've only got to have one type of coolant, I can use it for everything. Right, let's see, probably going to be, I want to come off the floor just slightly. Because I'm going to drill and tap through the part and I need a bit of clearance. Now I know this isn't necessarily the best way, but this is a one-off part. I'm not making any more of them. So in that sense, it's not worth the soft jaws and all that side of things. Now what we'll find is that when we're machining this, we'll actually mill through this piece, but that's fine because it doesn't matter, it's sacrificial, it's not a problem. So let's get this touched off on the corner and this top here. So in MDI, we'll call up the probe. Blow the coolant off of it. We'll handle jog it. Somewhere near. That's good enough. Go into our offset page and we just roughly part set 0 on that corner. Add the tool probe length. Call up our corner set program, into the memory, press cycle start. Some people say they can set it quicker manually, but I find that hard to believe. Once you've got the program in the machine and you've written it out what you want, this has got to be the quicker way, always, and more accurate. Definitely better than touching off tools with a bit of paper, and I found it a lot more accurate. Doesn't leave as many step tool marks, even though they are very small, as using what I was using before, like the tool setter there that you set up off the table or off the top of the part. Much better way to do it. So now we've got our G54 set right on this corner here. So now if we go back into the list of programs, I can call up Op2 and we are good to go. I'll show you that when it starts running. See you in a minute. Right, so it's just about finishing up on Op2. It's just doing a radius on the back part, and then it's going to come along and just engrave my logo in it. So we're nearly done. Last step here is the engraving. And the final op for this part is going to be, I think there's about 10mm material which is going to end up being on the back side, which is what I've been holding it with. I don't know if I'll bother doing anything in fusion with that. What I might just do is put something underneath it to stop marking the face, clamp it nice and tight, and then manually go over to the face mill, 3 or 4 passes, 2 or 3mm depth to cut, and just take that excess material off. And that is it. Let's see how it's come out. It looks good. It's about one end. Undo this vice. Stand you there a sec while I blow the part off. Let's come over here and we'll have a look at it. And there we have it. So obviously on this side it's not been held in that position to deburr this, so I'll do this edge by hand. That's how the part's going to sit on there once this excess material is taken off. So yeah, we'll take off this excess. I'll probably clamp it in a vise like that, put something under there to protect the face, and just manually skim that off level with this surface here. But really happy with that finish, and a nice little bit of engraving there for me company name. I'll go do this, I'll manually take that material off there, and then I'll bring you back, I'll mount it up in here and I'll show you the finished part. Okay, so we just manually faced off or removed the material that was left on the back of the part. We just used a 2-inch face mill there, clamped it in, use this to protect the face of the part, and this is the back. Not left the best finish, but to be fair, them inserts, I should have changed them really, they are worn out, but let's take it out. Stand you there for a second. So at the back of the vise, just left a couple of black marks in there, but I can rub them off. And let's plonk you there a sec. Hello, dog. Hello, Ruby. Come to see what the quality's like. Yeah? What do you reckon? Does that pass inspection? Is it good? Yeah? Not as good as treats. Good girl. Right, so what we've got, try and stand it up a little bit. So you see there, just the top of the vice left a bit of a dirty mark on there, so I'm just going to just clean that off quickly. Just help to soften up them edges as well. For the edges that haven't been in a cycle. I could do that as another op and come down and put the same chamfer on there, to be fair, but I've done this part manually with the deburring tool, and the same with that. Obviously this was done in the cycle, so it's just this backside that I need to take care of. So we'll just use a bit of Scotch-Brite for that. Again, it's not a part that you can see on that side of it, so it doesn't need to be fully deburred visually. It's just so you don't leave a nasty sharp part for anyone, because that is a real bad habit to have on anything. If you're cutting a bit of tube or if you're machining, anything you do, just to leave a sharp edge on it is just very half-hearted. Right, quick go over just where the logo is, the engraving, just deburrs that. The other thing you could do, if you have one, which I don't, but you could put this in a tumbler, but I'm guessing the majority of small shops or people like myself won't have that sort of facility. Right, so let's airline this off quickly. And myself. Still just needs a little bit more, just there, you can just see it. What I'll do is I'll get the deburring tool. Let's just do this without leaning over the camera, making it hard. Right. It's the only problem with Scotch-Brite, you get a nice layer of dust over everything once you're done. Let's just move that there. Load the bench off. Right. Now we are done. So there's the inside. There's that with the logo. I say logo just with company name, shall I say, engraved in there. That's come out really nice. And then let's show you it fitted. Put the 2 screws up here just for safekeeping. Right, okay. So what we need to do, something that I've just found. Is on this back edge, this one here, being flat, there's no chamfer on it. It's just making contact ever so slightly with the radius on the inside of this machine part here. So what I'll do is I'll take this and I might program a radius into it, or I might just put one on there manually for how long it's going to take, but we'll get that done and I'll bring you back. Right, after realising that the back side of the part touched the radius on the pulley mount over there, I decided that I'll come back in, and while I'm there I will do an op 3. I wasn't going to, but decided I will do. So we've programmed G54 over in this back corner here, if you can see that, probably not very well. And then we're going to run a chamfer tool around the inside and outside profile, but not this back edge because that's already got a radius on it, for the 2 holes. And then this front section here that I'm highlighting, we're going to put a really deep chamfer on it, almost all of the tool that I've got, just to clear that, and that should do the job. So if I show you it, let's just go out of that one, come to this, turn off model so you can actually see it. So we've modelled this one, rather than from stock, it's from solid. And there you can see chamfer, back of the holes, around the profile, and then a real deep one at the front, and that should clear the section on the pulley. It's just a little bit nicer than filing it or linishing it off by hand. So we've got everything in the machine. There's the parts. We set our G54 this time off this back corner. This is just protecting that face to stop it getting marked. Same again, a bit of alley strip in there to protect the engraving, and also that will stop that flexing down. So let's run it. We're in the right spot at least. There's nothing worse than getting to your final op and ruining a part you spent ages on. And believe me, I've done that. All part of the learning process. The only thing I'm slightly concerned is that the large chamfer that I've programmed on that section is going to come down and do it in one hit. Hopefully it won't be too much pressure on the tool. Take this out of the box now. Just put you down, so I need 2 ends to undo the vise. Take our part out. Right, so now you notice I've gone slightly too deep with that for that tool. Could have done with a bigger tool. All it's done is put a slight step in the back, which, to be fair, may even help us a little bit more. So I'll just rub that to deburr it. If you hadn't have put that step in, it wouldn't have left another burr. I seem to be going from one extreme to the other. There you go, so we've got a nice, at least it's uniform, it's machined in there, it looks nice, it looks like it's supposed to be there rather than grinding it. And now let's see, that looks like that clears. So we'll now get this in place. Knock the camera there. Do that up. Bit of dust off the Scotch-Brite there. And there you have it. That mounts on there. Lovely. There's a pickup, the trigger. So let's now put our sensor in. So we just used a little button head with a spring washer. And there we have it. That's that part complete. Looks really good there. Not that you're really going to see it because it's towards the back of the engine, but it still can be seen if people are looking around it, so that'll look good. You've got the trigger there within the air gap distance. The air gap for this in the spec sheet is between 1 and 2.3 millimeters, I think, and that should be, I haven't got anything here, that's 1.5. I know that because I've used that for stuff before. That's 1.5 and that's just about touching, so that's a good gap. That's nice and rigid, looks good. Part done. So there you have it. Try and get a better picture on there. That's the part all finished. Hope you enjoyed watching the video. I'll try and get and do a few more soon. Every day I'm learning on the machine. I have a few mishaps, crash a few tools, ruin a few parts, but as you're learning, that's pretty much part of the process. I think you're lucky if you don't. And when you've got no one to teach you and you're learning it on your own YouTube videos, then you've got to expect some sort of error. But I'll try and make as little mistakes as possible, but sometimes it's unavoidable. And I've got a little clip here that I'll show you at the end that I'll add on, so stay watching and you'll see one of them. Right, thanks for watching. See you soon. Okay, so let's run op 2. The part's in there, the vice is tight, G54 set on that front corner, the program's in the machine. I think this one's only 5 minutes. Let's go. And there we go. Right, thanks for watching. See you soon.